Hello everyone and welcome to this section. I'm really excited to discuss or to go through this section because in this section we're going to learn how to represent an image in a digital format, and that's one kind of a very important building block that we're going to build upon and use when we build our machine learning algorithms moving forward, and how can we use it as well to do all the image manipulations in the next sections. All right, so before discussing how can we represent an image digitally, what we want to do here is we want to learn how do humans see colors in general. All right, so let's assume that we have this banana, and we want to see how humans with their set of eyes, for example, and with the brain can see the color yellow, for instance. All right, so in general what happens is when light is reflected across that banana, the wavelength of the light reflected is within that range. That's pretty much the range of the wavelength of the lights reflected through our eyes. And that's kind of the visible spectrum that humans could see. So as you guys can see here, from 400 nanometers to around 700, that's kind of the colors ranging from blue moving forward to green, yellow, red, and so on. Since we lie kind of in here for the yellow color, which is the banana, that's what's between 570 to 580 nanometers. All right, so simply the light waves that reflected off the banana and hit our eye has a wavelength from 570 to 580, and that's kind of the wavelength of the yellow light. All right, and that yellow light this image is sent through our optic nerve and then translated in our visual cortex as as a color yellow or color red or whatever. All right, and that's pretty much how humans see color. And right now what we're really interested in, how can we represent an image in a digital format? So let's take a look at how can we do this. So before jumping into a colored image, what we're going to do is that we're going to discuss grayscale image, which is just kind of black and white image. So let's take a look at this image, for instance, which is kind of the image of the Mona Lisa. And what we're going to do, what happened is, this image is stored digitally in the form of pixels. Each pixel has a number in it. That number ranges from 0 to 255. If we put 0 within a pixel, that means the color is black. If we put 255, so as you increase the number, that means we're increasing the brightness, we're moving forward into a white color, within the image. So as you guys can see here, if we have let's say this black dot within the image, it's actually if you dig into it, you will see in this pixel there's a value of 0. That means the color is dark. If you go, let's say, to here, or here maybe it's a little bit lighter, you can reach, for example, 255, which is pure white. What's happening in between? So actually in between, there's different shades or different colors of our gray. All right. So as you guys can see here, if we have 0, that means black. 255, that means white. In between 155, that means we are kind of in a gray color. All right, that's great. So that's how we represent an image in a kind of a decimal number format. What if we want to represent an image what we call in a binary format? And that's how actually the image are stored within our computer. For those of you guys who are not familiar with binary numbering, again, it's very simple. It's just instead of having decimal numbers, which is range from 0, let's say, to 9. What we could do with that, we could just use binary format, which is only a number that's 0 and 1 in a very simple term. So simply, number 255 is actually represented digitally as a bunch of ones, bits, 8 bits, of ones. All right. And that's why you will see 255, that's actually 8 bits, and that's why the 8-bit image came from. That means each pixel has 8 bits, which is just represented as as 1 byte. All right. As you guys can see here, we have 4 and then 4. That means we have 8 ones. That means 255. What if you have 0? That means all of them are zeros. What if you have 155? That means we have a bunch of zeros and ones that represent that number 155 in decimal. Again, if you guys are not familiar with the binary or you don't interested, that's fine. This just I wanted to give you an idea of how can we restore an image digitally. But all what I want you to care about is the actual decimal representation of the number, which is this basically. Number 0 indicates black, number 255 indicates white, what's in between indicates gray, and that's how can we build our image which is what we can see here by just having a bunch of pixels. Each pixel has a certain number, and that's pretty much it. All right, perfect. All right, so the next step is, okay, we want to represent an image in a colored space, in a colored format. Okay, so in a grayscale, we just have kind of, one layer, and each layer has different pixels, and each pixel has different number, from 0 to 255. For colored image though, we don't have one layer. We have actually 3 layers, or 3 images, representing the colors red, green, and blue. And that's where RGB came from, kind of the code came from, okay? So each pixel, so if we just take a look at any colored image, if we take, for example, this pixel, so each pixel contains 3 values, okay? And each value actually contains a number from 0 to 155. So each pixel has 8 bits, all right, times 3 in a way, okay? All right. So the RGB image is actually split into 3 matrices corresponding to red, green, and blue, all right? And by mixing these colors, red, green, and blue, you can actually come up with whatever mixture we have, all right? And I'm going to show you an actual real example right now where we actually build different colors as we go, all right? So what we do again, if we assume that we have this image, what we do again, we divide this image. Let's say each of these images has certain pixels. Here, obviously, this is like a very large representation, but in general, like the actual image has different pixels. And within each pixel, there is actually different layers in a way. We have red, we have green, and we have blue. We call them channels, red, green, and blue. So that's pure red, that's pure blue, and that's pure green. And if we actually start mixing them up together, we come up with newer colors, okay? Surprisingly, if we mix up red and green, we come up with a color yellow. If we mix blue and red, we come up, with this color, like pink color, for example. And so on and so forth. That's how we come up with different colors, and we mix up all the different colors that our eyes can see. All right, it's fascinating. All right, so how can we represent again an image or in a colored format? Again, if we have this image, what we do here is that if we want to represent a red pixel, okay, that means we have, again, remember it's RGB, right? So we have our red, we're just gonna have 255 in red, and we don't have any green, and we don't have any blue, that's why it have 0, 0. So each pixel, there's actually 3 values in it, and each value is represented in 8 bits, all right? Which means I have a 24-bit color, and that's where the 24-bit color came from, all right? Okay, so again, for the colored image, actually the number of the size of the image obviously is 3 times the grayscale. Why? Because we have, kind of a grayscale image, but we have actually 3 of them. And we interpret colors by mixing the 3 pixels, all right, together within the 3 layers or within the 3 channels, RGB, RGB. If we want to represent the color green, actually our color green is 0, 255, and 0. If we want to represent the color blue, it's 0, 0, and 255. What if we want to present yellow? Let's mix 2 colors together. That's where we can get, RGB, which is we're going to get the red, we're going to get the green, and we'll make them 1s, and we'll set the blue to 0. And that's pretty much how we get the color yellow, and so on. All right? Perfect. And again, that's kind of the matrix that we're representing here. Okay. And that's pretty much all what I have for this section. I hope you guys enjoyed it. And now we know how can we represent an image in a grayscale on color format digitally. I hope you guys enjoyed that section, and see you in the next section.